Okay. Hi everyone. So now we're going to go over algebraic expressions. So a variable is a letter representing a number from a given set of numbers. So here are some examples. So like x would be a variable, y would be a variable, and z would be a variable. So together with variables we can form polynomials. So a polynomial with variable x is an expression of the following form. So an and all the a's are known as coefficients, and then the x's are a variable. So together they form a term. And all the a's are from the real numbers, and then our degree n is the positive integers. So if our leading coefficient is not 0, then the polynomial is known to have degree n. So our degree is going to be the highest power of a variable that is there. So for example, in x9 plus 6x, the second x is just a first power, but the highest power is 9, so that is going to be degree 9. And then our other one, the common quadratic, is degree 2. So in simplifying polynomials, we typically combine like terms. And so like terms, I'm going to go ahead highlight that, are terms with the same variable raised to the same power. So in 3x plus 7x, we could combine those because both x's are raised to the first power. So we're just going to add 3 plus 7, and we get 10x. 7y squared minus y squared, we could also combine because they're both the y variable raised to the second power. And then we get 6y squared. Once you get the hang of it, you won't have to write 3 plus 7 or 7 minus 1 in parentheses, and you'll just be able to get the final answer. So here's an example if you guys want to go ahead and try it on your own. Go ahead and pause the video and see if you're able to do it. Okay, hope you guys were able to work through that, but let's go ahead and do it together now to check our answer. So here we're able to distribute the 6. So let's go ahead, the negative 6. And then we're going to distribute the 10. So let's go ahead and do that. So we're going to get negative 12x squared minus 24x plus 40x squared plus 30x. And then when we combine those, we're going to combine like terms. So here's an x squared, there's an x squared. Here's an x, there's an x. So now we can get 28x squared plus 6x. And that's our final answer. Now in the product of polynomials, when we have a plus b, c plus d, what I usually do is I draw arrows. So I do the first term. Okay, we're going to go ahead and multiply that times this term and multiply it times this term. And then just do it for how many terms there are. I'm like, okay, now I'm going to go to the next term in the first, parentheses, multiply it by that term, multiply it by that term. I think that is usually easier to remember than doing remembering FOIL, because I feel like it's hard for students to relate using FOIL for like trinomials or just longer or like a higher degree polynomial with more terms. So I just usually just draw the arrows. So our example is 3x plus 4, 6x squared plus 7. So I just do the blue first. So I'm doing 3x times 6x squared. So that's 18x. That's going to be 18x. Oops, that's supposed to be cubed. Sorry. My 2 turned into it's supposed to be a 3. Okay. Sorry about that. Okay, let's start from scratch together. So 3x times 6x squared, that is 18x cubed. 3x plus 7 3x times 7, 21x. Then we do the next one, so 4 times 6x squared, that is 24x squared. And then 4 times 7 is 28. So there we go. And then there's no like terms here, so we don't have to combine anything. Okay. And then here's another one. So you guys could think about how to solve that, and I'll give you some time to do that and pause the video. Okay. So I'm not going to solve it, but I'll show how to draw the arrows. So usually it's going to be 2x times x squared, 2x times 4x, 2x times 5. And then you add it to 3 times x squared, 3 times 4x, and 3 times 5. And then you just simplify that. Okay, moving on to factoring polynomials. So usually we use the distributive property to expand algebraic expressions, which is what we've done in the examples above doing products of polynomials. So factoring polynomials is like the reverse process. So we're going to factor an expression to find it as a product of simpler ones. So basically like this, these up here would be like the factored form of this long polynomial. So factoring is the breaking it into a product, and then expanding it is just writing it out as its full polynomial form. So ways to factor, you could factor by common terms. So that's basically taking out factors of like numbers or like factors of variables. So here we could factor out a 9x squared from 18x cubed and 27x squared. So when we factor that out, for the first term we get 2x, and then for the second term we get 3. And then we could factor the 9x squared, or just like move it up front, and then we could combine the 2x and then the 3. And the reason that we could do that is because the numbers are commutative. And now another example, here x plus 3 is the like term or the common term. So we could just factor that out and then combine the x squared plus 5. Factor by grouping is when you have 4 terms. So usually I like to make sure that my terms are in an order where I know I could factor something out of them. I wouldn't want to group x cubed and 12 because I can't factor anything out of that. But here I drew parentheses around the groups that I know I could factor. So the first one, I could factor x squared out and be left with x plus 4. The 3x plus 12, I know I could factor out a 3. And the goal is to get these the same, so that we're able to just factor that out in the end and then combine the x squared plus 3. So in factoring trinomials, we are able to do it in 2 different ways, but they all have the same method really. So the first one is when the leading coefficient is 1. So the way I was taught is doing the x method. So with this way, you multiply this term times this term, put it on the top. You just keep this term and you put it on the bottom. So usually when this coefficient is 1, it's just 1 times whatever this coefficient is. So we have negative 18 on the top and 3 on the bottom. So the goal is for this number, so 6, we want 6 times negative 3 to equal 18. But then we want 6 plus negative 3 to equal the bottom term. So really, if our a is 6 and if our b is negative 3, we want a times b to equal the top, and then a plus b to equal the bottom. So once we get those, we're able to put them with the variable x. So we just keep the 6 and the negative 3 as is, and then we keep it as x plus 6 times x minus 3. And that's how we find our factored polynomial. So when the leading coefficient is not 1, what we want to do is the same as like before, but our leading coefficient is 8. So we're going to do 8 times negative 3 to get negative 24. And then we're going to keep this term here. So it's the same as before. We want negative 12 times 2 equals negative 24. But then negative 12 plus 2 equals negative 10. So something that's different when the leading coefficient is not 1 is instead of just placing those numbers from our x method straight back in as our factored polynomial, we're instead going to factor by grouping. So we're just going to move these, and that's going to be what replaces our like bx term. So that replaces the negative 10x. And then we're going to factor by grouping. And again, the goal is to get these two to be equal. So the first term we can factor out 4x and get a 2x minus 3. And then the second term we just factor out a 1. We're just going to leave it. So we could combine the 4x plus 1 and then the 2x minus 3 for our factored terms. Okay, and then go ahead and take a look in the textbook and learn what perfect squares and differences and sums of cubes are. Those are super helpful, but I'm not going to go over them, but you guys could definitely check them out. Okay, I'll see you when we transfer to our next section, which we're going to learn about rational expressions in 1.4. See you there.